piecewise linear model. So what is piecewise linear model? This time, if you are using a diode in forward bias, okay, if there is a forward bias on diode, okay, and of course that forward bias should be greater than 0.6 voltage. Okay, so if I say the diode is greater than 0.7 volt, okay, for silicon, and VD is greater than 0.3 volt for germanium, okay, in that case now your diode will be replaced by a resistance and a battery. Okay, if it is silicon, it is a 0.7 volt, or if it is a germanium, it will be replaced by 0.3 volt, and this is called your forward resistance. RF is the forward resistance. Forward resistance. Okay. And similarly, if you want to apply reverse bias, okay. So for reverse bias, this is your diode, and you're applying the reverse bias, then there is no change, exactly like reverse bias. Then you can replace diode, okay, that is VD is negative. Then diode can be replaced by a open circuit. Same way. So only now additionally one resistance will come, okay, and that value will be given to you. And if your voltage is less than 0.7 volt for silicon, then also this will be open. So that you have to keep in mind. And now let us solve some problems for this one. So basically now if you see the IV characteristics of this type of diode, this type of model, okay. So now diode has a resistance also. So it will start from 0.7 volt and it will be like this. Okay, that means straight is PVD upon ID. That means that is the resistance has some slope. Okay, so if it is a perpendicular, then it is a zero resistance. Now it has some. If you take the slope of this one, it will give you some forward resistance also. So that is the equivalent model or equivalent IV characteristics of for this given model. Okay. Now
फिर एक्सिस में वेडी नहीं आना चाहिए.
एक्सिस में वीडियो होगा, सॉरी, एक्सिस में वीडियो होगा, ये आईडी होगा, and this will be your 0.7. So problem is, we'll do one or two problems. Okay, the showing the examples of this model. So now let us say you have a diode 5 volt, you have a resistance here, and you have been given a diode. Okay, and the resistance value is 1 kilo, and diode has a cutoff voltage P gamma. This time is 0.65 volt is given in the question. Gamma, okay, cutoff voltage. This is not R, this is not reverse, this is gamma. Okay, gamma. And forward resistance is also given as a 20 ohm for this circuit. So they are asking find the ID in the circuit. This is the ID flowing in the diode. So say find ID, and then you have to find the VR resistance across this this resistance R. Okay, and you have to find voltage drop across diode already known. So that is voltage across diode. Okay, voltage across diode you have to find out, that is VD. You have to calculate. Okay, and VD is defined like this. So now it's easy. Okay, now because if you make, I would make it open, so you open, if you make it open, this will be 5 volt coming here. That means we can assume safely the diode is forward bias, and I can replace this circuit by a 5 volt. Okay, and then we have a resistance 1 kilo ohm, and then I can replace this by a, say, battery and resistance, a resistance and a battery, or battery resistance, you can make it up and down, no issue. Okay, so this will be 0.7 volt. Okay, because silicon it is given 6.5 is given. If it is silicon, that is 0.7, but it is specifically given, and this is a 20 ohm resistance. Okay, and ID is flowing through the diode. Okay, so I can find now what is ID. So ID will be simply your 5, this 5 volt minus this one 0.65 volt, and total resistance, that is 120 ohm. Okay, so this will give me how much? Tell me. 0.354, so 1.35, and this will give you 1020. Tell me how much current is coming.
सर ऊपर 4.35 आएगा, है ना?
4.35.
एंड करंट 4 मिली एम्पियर आएगा नेट डिवाइड करने के बाद.
आएगा
4 मिली एम्पियर, 4 मिली एम्पियर.
4.26 मिली एम्पियर exactly.
यस सर, 4.26 करेक्ट, ये आ रहा है.
4.26
मिली एम्पियर,
milli ampere current will come. Okay,
2647.
okay, and now you know the current, so you can find a VR. VR कितना हो जाएगा? 4.6 watt 1 kilo ohm into 4.26 milli ampere. Milli ampere आप किलो कट जाएगा, तो you have 4.26 volt. Okay, and B diode कितना आ जाएगा? B diode will be 5 minus this 4.26. 4.26, that is how much? 0.74,
0.74.
0.74 volt. Okay, so if you want to voltage according to small RF, okay, that will be 0.74 minus 0.65, because this is 0.65 and this whole is VD is 0.74. So if you find voltage here, okay, either multiply this 20 by this one, okay, or directly you can find from here. Tell me how much will come. कितना आएगा?
0.09.
0.09. Okay, volts. So in this way you can find, or you can multiply this for this ID 4.26 with this 20 ohm. So that should also give you same thing. So now you can solve the things. Let me give you one more question. I guess some homework कोई भेज नहीं रहा है क्लास का.
सर एग्जाम है गेट का परसों, थोड़ा उसमें
हाँ,
सभी लोग हैं, ऐसा भी चीज. संडे को भेजते हैं. सैटरडे को एग्जाम है.
so the next question is giving what we used earlier. Here 9 volt. Okay, here it was something called 600 ohm, 300 ohm. Okay, and here is the diode, which is ID. Okay, and here you have one more 100 ohm resistance. So I'm using the same question, only the model has been changed. Okay, and for this one they have given you V gamma silicon diode is there, the silicon diode. So your cutoff voltage is 0.7 volt, and RF is again given 20 ohm. So this is the question. Now we can, so we had already done this question earlier na, with Thevenin theorem. So you should maybe remembering the Thevenin voltage was how much? Thevenin voltage was, tell me how much Thevenin voltage? 3 volt. this question. Okay, if I make it open, just make it open. If you want to replace, you can replace here directly with diode and resistance. Okay, but I am removing this as this fully. Okay, as it is I'm removing. So this is open circuit, and the resistance here is how much equivalent resistance R Thevenin. R Thevenin will be 600 parallel to 300, that is 900, and plus this 100. So this is 1, this is 3, this is 200. So that become 300 ohm. So this question I'm already done, so I am not doing repeating. So this is 300 ohm is replaced, and now diode, I can put a diode here back. Okay. Now diode is forward bias. Okay, so I can replace this diode by a resistance and battery. You can put resistance earlier also, that will be then included it in the if you put resistance also, then it will be included in the here R Thevenin. Okay, or later you can also replace. So this is 300 ohm, and this is your small resistance. You have a diode will be replaced by 0.7 volt battery. 0.7, this is 20 ohm, and this is 3 volt. Okay, so tell me कितना आंसर आएगा? में कितना आएगा आंसर सॉल्व करने पे? So if you solve this one, if you want to find ID here, ID, so ID will be this 3 volt minus this 0.7 volt divided by 320 ohm is 1230, and this answer will come around 7.1 F milliampere. Check it.
Yes, sir.
So is there any student who's having problem in this one? So this is your models we have discussed. Okay, now I'm discussing the model. I want to discuss one more application of diode. Okay, so basically we can do clipper clamper first, but it will be good to if I do Zener diode, discuss Zener diode first. Okay, because Zener diode also used for clipping clamping. So let us start with the Zener diode now.
सर एवलांच ब्रेकडाउन डिस्कस नहीं करें बाद में?
करेंगे Zener diode, Zener breakdown ना करेंगे, अभी कर रहे हैं Zener diode. So Zener diode is basically what? Okay, Zener diode works in the reverse bias. Works reverse bias. This is your say Zener diode. So now if you apply reverse bias here, plus minus here, reverse bias here, okay. So in reverse bias, for reverse bias, okay, this Zener diode can be replaced by a battery. Okay, if the say set Zener voltage for this diode is okay VZ, so this can be replaced by a battery like this. Okay, now you see where is the plus negative plate, where the battery plus comes, it will be replaced by VZ. Okay, so why it is so? So for that you have to see the IV characteristics of Zener diode. So if I say this is my I and this is my V, okay. So Zener diode in the forward bias, okay, there is no change. It exactly behave like an ordinary diode. Okay, so you can replace ordinary diode. If it is the ideal, you can, or if you plus is here minus here, then you can write forward bias. You can write that is it will be replaced by either 0.7 volt or it will be replaced by short circuit. Okay, so Zener diode in the forward bias like ordinary diode. So Note this point. So Zener diode behaves like an ordinary diode in forward bias. Okay. So both side it will be replaced by battery. Or okay, it's 0.7 or and the reverse side, if it is reverse bias, it will be replaced by battery VZ. Okay. So what happens in the uh, reverse bias? Reverse bias, if you say the constant current flows, okay, this original diode, a constant current flows and like a particular voltage VZ, okay, that is called breakdown voltage. What happens? Suddenly a large amount current start flowing. Okay. Now the voltage across the Zener diode will not change. Voltage will remain the constant across the Zener diode, but current can also keep on increasing. Okay. So now there is a limit. Okay. This is called your IZ minimum. IZ minimum. Okay. IZ minimum is what? The current, minimum current required to make diode turn on. So IZ minimum is what? Okay. Minimum current flowing across Zener diode to make it conduct. Okay. So minimum current flowing across Zener diode to make it conduct. Okay. Make it conduct is called IZ minimum. That means whenever Zener diode is just on, okay. Suppose this Zener voltage is 5 volt, and if you apply 5 volt, that time a minimum current will be flowing in that Zener diode. That is called IZ minimum. Okay. Now, if you again keep on changing the voltage across the Zener diode, so what will happen? The voltage will become constant. You can see the IV characteristic. Voltage is not changing, so the diode voltage will be VZ across, but current can keep on increasing, and at max we can go up to IZ max. These are performance parameters. These are parameters. Okay, critical parameters for Zener diode. So I will go up to IZ max, because if I keep on increasing the more voltage, if I go beyond the IZ max, what will become? Your diode will get burned. Okay, so that is the limit. Okay, you have to apply this power rating. You should not go, current should not go beyond IZ max, otherwise it will burn. Okay, so this is the IZ max is what? IZ max is the maximum allowed current. Maximum allowed current through Zener diode. If current goes beyond this one, okay, so then this will burn. Okay, and if I want to get how much power it dissipating, so you can simply find how much IZ is flowing and what is the voltage across this one, which is constant, and you can find this one. So this will the power dissipated by the Zener diode. Okay, power dissipated. Okay, and the maximum power Pz max is given by Iz max into Vz. Okay, so when the maximum current is flowing, that time it will dissipate maximum power, and which is given by this equation. So sometimes the question Pz max will be given, Vz will be given, Iz max will not be given. So you can find what is the value Iz max by noting the what is the Pz max value. Okay. Now, so this is basically your Zener breakdown. Okay. So Zener breakdown, what is the difference between a normal diode and this PN junction diode? Okay. Generally, when we make a PN junction diode, so you make P and N. Okay. P and N, and in between there is a depletion region. So N side you have a donor impurities. Okay, I will told and it's the minus acceptor impurities. Okay, and it has some width W. Okay. Now when you making Zener diode, that time what you do, in that case, what happens, the doping is very high. Okay, doping of either P generally P, you can make P doping very high. It's P plus plus. So once you make the doping of P and N region, okay, you make both P and N region very high. Okay, so doping is very high. Okay, so say doping of P and N both, okay, region is very high compared to the ordinary diode. So when the doping is very high, in that case, what happens? This thickness, this width, okay, width is very small. So this width is small. Width is small. Okay. Now, when the width is small, what happens? The electric field is voltage. You're applying voltage, okay, 5 volt, suppose, and if this width is in the micrometer, okay, micrometer. Then the electric field is very high. For example, if I say the VZ, if I want to find electric field is what P by W across this width. If I say this is my 5 volt and I say this is micrometer, okay, micrometer, that is 10 by minus 1 meter. So what will become? This become what? 5 into 10 raised to power 6 volt per meter electric field. I'm giving example, okay? This electric field can be very high. This generally width is very less compared to the ordinary junction. If ordinary diode has a micrometer, it may have 0.1 micrometer, okay, or 0.01, means it comparatively is low. So here electric field is very high inside the depletion design. Electric field is high. So what happens? This electric field is so high. What happens in the junction? You have a discuss here. So you have a PN junction, okay, and you have this in between you have this silicon atoms, okay, silicon atoms, and you have suppose impurity also there. Impurity say, and one side is aluminum impurity, P and both type impurities are there. So basically you have a silicon structure, okay, with impurities also here. So now when you are applying very high electric field, what will happen? This bond will get broken, okay. So when with this electric field is very high, so when this bond get broken, what happen? Suddenly you have a large amount of free electrons. Okay. Now this region is not a barrier; it's become like a conducting region because so many free electrons comes. Okay. So what happened? So many charge carriers are produced, and that gets swept away to the outer terminals, and you start getting the very high amount of current. Okay. So that is the working mechanism of Zener breakdown. Okay, if it is an avalanche breakdown, that is a slightly different mechanism compared to the your this Zener breakdown. Zener breakdown, here field is itself field. This is a field assisted breakdown. Okay, so what is Zener breakdown? Zener breakdown is field assisted breakdown. Okay, and if you increase the temperature, okay, then Zener voltage will decrease. Now suppose at 300 Kelvin, you have a Zener voltage 5 volt. If you make the junction temperature 400, then you may require only 4.8 or 4.7 volt. So temperature coefficient, okay, temperature coefficient of VZ, that is delta VZ upon delta T, okay, is negative, okay. That means if your temperature is high, then you Zener breakdown voltage will happen in lesser voltage, okay, because temperature itself is helping to reduce this width, because temperature itself producing charges, okay. So when you temperature itself is doing the same work which is this field is doing, that means it is temperature also assisting this field. So if you higher temperature, already the width is small, depletion layer width is small, depletion layer width depends on the temperature, okay. So and this is the cutoff voltage, So higher the temperature, lesser if it temperature increasing, the cutoff voltage also decreases. So cutoff voltage decreases, that means now you require, so you have to remember these 2 points. Okay, this is the field assisted breakdown. Okay, and the temperature coefficient Vj, that is d by g upon dt. This is T is temperature. Okay, it T is temperature. T is temperature. It is negative. Okay, now in the case of avalanche breakdown, okay, just remember, I will not discuss it in detail.
सर
Avalanche, tell me.
सर सर इसमें टेम्परेचर के इंक्रीज होने पे बिर्थ कैसे डिक्रीज हो रहा है, थोड़ा उसका मैकेनिज्म बताओ ना हम सर।
फिर टेम्परेचर विथ होने से क्या वो उसके लिए आपको विथ का डिपेंडेंस देखनी पड़ेगी टेम्परेचर से। ओके,
ओ
हाँ, सो वो फॉर्मूले वगैरह तो आप उसमें बुकलेट में दे रखे हैं ना उसमें।
ये सर मैं हम देख लेंगे।
हाँ हाँ, उसमें
ठीक है।
देखना, फिर डिस्कस करेंगे इसको। ठीक है, तो यार हम क्या खाली यहाँ पे हम इसकी सर्किट एप्लीकेशन देख रहे हैं। लेट मी आई एम टेलिंग समथिंग यू दैट यू रिमेंबर, बिकॉज कंडक्टिविटी कट ऑफ वोल्टेज डिक्रीजेस। कट ऑफ वोल्टेज क्या होता है आपका? कट ऑफ वोल्टेज बेसिकली आपका फंक्शन ऑफ टेम्परेचर होता है। ओके,
हम्म।
कट ऑफ वोल्टेज डिक्रीज हुआ क्योंकि आपका डोपिंग जो भी होगा, इफ टेम्परेचर इंक्रीजिंग, आपका नंबर ऑफ फ्री चार्जेस आर इंक्रीजिंग। ओके,
यस सर, यस
that
सर।
so because of that one, this cutoff voltage will decrease. Okay, and this will depend on temperature. Okay, and next is your avalanche breakdown. उसको खाली भी याद रख लो, बाद में फिर discuss करेंगे। avalanche breakdown, avalanche breakdown, avalanche breakdown happens in the normal PN junctions. Okay, normal PN junction down. So that is happens because of impact ionization. Impact ionization. Now impact ionization is what? Impact ionization का मतलब क्या होता है कि you have some electrons. Okay, you have electrons in the junction, free electrons in the junction. Now if you are applying the voltage across this one, if you're keeping the voltage, so what is happening? Because of increase of voltage, the kinetic energy of electron will increase. Yes or no? Okay, so if the kinetic energy of electron increases, it will go and strike the bonds. Okay, and it will make further more electron will free. Okay, so suppose you have one electron and it collides with some band, so it will free two electrons, and this free two electrons again will collide with more bands, and they will start making free four. And this way this process will keep on continuously, and there will be large amount of free electron. So this is called cascade process. Cascade process. Okay, so large amount of electrons will get free. Okay, when you are increasing, so kinetic energy. Okay, kinetic energy of electron, kinetic energy increases. Kinetic energy increases. Kinetic energy of electron increases. Okay, and because of increase, they break the bond and new electrons are released, and the electron further releases, breaks more bond, and more current happens. So this voltage is generally higher than the this Zener. Okay, Zener avalanche happens generally at lower voltage. So suppose Zener voltage happens on 5, PN junction may happen on 7. Okay, like this difference is there. And the temperature coefficient of avalanche breakdown, okay, normal breakdown has a positive temperature coefficient. So avalanche breakdown voltage has positive temperature coefficient. Okay, positive temperature coefficient means your dVb, this is breakdown voltage, dt is positive. That means if you increase the temperature, breakdown voltage will also increase. Okay, so suppose at 300 Kelvin the breakdown happens in 7 volt. At 400 Kelvin the breakdown will happen at 7.5 volt or 7.4 volt. Why it happens? Because when you are increasing the temperature, okay, so you know what happens with electron. If you are increasing the temperature, that means this electron random motion will increase, or you can say there is the silicon atoms, okay, inside the crystal. Okay, and when you are supplying the temperature to this silicon, they start vibrating. That motion is called what? Phonon vibration. Okay, phonon vibration means the atom motion of atom. So basically any crystal is made of atoms, ions, okay, and this ions are always vibrating, okay, and their amplitude is always proportional to temperature. If you increase the temperature, kinetic energy, the amplitude will increase. So now what happens when you are applying temperature? So what happens is the amplitude of the vibration will increase. So there will be more collision for this electron. So what happens? You are supplying the voltage at the junction, and you are giving high energy to this electron, but because of this collision process, phonon scattering, because phonon scattering is coming, so these electrons are losing energy. So if you want to get same amount of energy for breakdown, you have to apply more voltage. Are you getting? Here here that is scattering is the opposite of your phenomena, because this is the impact ionization. Electron has should have energy, and but if you are increasing temperature, electron will get scattered and the energy will lose. So they will not find the energy to break further bonds. So you have to supply that energy by applying external voltage, so that you need more breakdown voltage. This one, okay. So we will discuss this thing later, okay. Just keep in mind those things, that is the field assisted breakdown. This is impact ionization. This happens due to impact ionization, okay, of bonds, okay. Impact ionization bonds, it has a negative temperature coefficient, it is a positive temperature coefficient. If you don't know this one, that was enough, okay. इसी में यही क्वेश्चन आता है, कुछ नया क्वेश्चन नहीं आता इसके अंदर. So now we'll come back to the our uh, normal thing. So what is circuit applications? Circuit applications में क्या है? This is your Zener diode. Okay. Now you are applying this plus here, that will be replaced by VZ. Okay. VZ, and in the reverse bias. Reverse bias. Okay. And the forward bias, what will happen if you apply forward bias to this Zener diode? Okay, plus minus here. So this will be replaced either by silicon. If it is silicon, it will be replaced by 0.7 volt. It will be replaced by 0.7 volt, like ordinary diode. Okay, forward bias. It will be replaced by 0.7, or it will be replaced by a short circuit if it is ideal, for ideal case, for ideal case. So here important thing is that reverse bias is important for us in the case of Zener diode. Okay, and don't do mistake in the exam. Minus plate will be replaced by plus. Okay, so both time it will be replaced by battery. Here also battery, this also battery. That you can keep in the mind. So let me give you one question and explain the Zener diode. So now, what is the role application of Zener diode? Zener diode is basically is used regulating power regulator. Okay, so power regulator is used as a power regulator. Okay, so let me give you the example for circuit, power regulating circuit. Okay, so voltage regulating, power regulating, or voltage regulator. Voltage regulator. So voltage regulator circuit. Regulator circuit. Okay. So what is voltage regulator circuit? So you have a battery, say VI, V input I am applying here. Here we have a resistance R. Okay. And here I am keeping a Zener diode. And here I am putting a load RL. For this one, this is your VZ, Zener voltage is VZ. Okay. Now let me give some value here. Say this is my 40 ohm. This is my 100 ohm. This is my 100 ohm. Okay. And the voltage has 10 volt. So this is the main circuit. All calculations you have to do in this circuit. Okay. different type of a variety of problems can be designed on this only in this single circuit. So you just have to understand this circuit proper way. Okay, so the first thing always is there that you want to make this Zener diode on. Okay, so if you want to make it on, what happens? You have to check what is the voltage across this Zener diode. If you know the voltage across open circuit is greater than Vz equal to greater than Vz, that means your Zener diode is on. And once it is on, so if this voltage is Vz, this is Vi, so here voltage will be what? Vi minus Vz across R. This will be Vr. This Vr will be already fixed. This is given. This is on. So automatically you know this what is this one. Okay. Now once you know this one, automatically you know how much current is flowing, IR. Okay, how much current is flowing, IR. So IR will be what? IR will be your this VR upon R. You can find the IR. Now you know this IR. Okay, and this voltage is fixed. And this is the parallel to the load, and load is also fixed. That means this load voltage is also fixed. So load voltage is equal to what? Load voltage is equal to the Zener voltage. Okay, and that is equal to, again, if I say this IR current is coming and the current in the load is IL, so that will be given your IL into RL, RL into IL. Okay, so now you know the IR, you know the IL. From here, you can find out how much current is flowing in the Zener diode, because your IR is only equal to your IZ plus IL. Okay. So if it is on, you can immediately find what is IZ, IR. If it is not on, then, okay, if Zener diode is on, then this is the case. So you can write here, if Zener is on, if Zener is on, then you can apply, you can
सर
then
जीनर इज ऑन मतलब इट इज रिवर्स बायस.
रिवर्स बायस है, और इसके अक्रॉस द वोल्टेज जो है वो है Vz से ज्यादा है, Vz या Vz से ज्यादा है.
ओके सर.
Okay, so in that case you can apply this equation, that is Vr upon I, that is Vi minus Vz upon R, to find I. And once you know the I, and you can find the VL from this formula. Once VL is known, you can find the IL, and once IL known, you can find the IZ from this equation. That will be your IR minus IL. And if IZ is given, you can find the how much power dissipated in the Zener diode, that will be VZ IZ. Okay, if Zener is not on, then no current will, then IZ will become 0. This will be open, it will remain open, and this IR will become IL, whole current will go here. Okay, so tell me if this thing is clear to you.
Yes, sir.
Okay, I'm repeating again. First, you have to check Zener diode is on or off. Once it is on, okay, on, so this voltage will become fixed. That's why it is working as a power power voltage regulator. This voltage is always fixed. This voltage is fixed. If this voltage is fixed, this voltage is fixed, this voltage is fixed. Okay, if this voltage is fixed, you can find voltage, this minus this divided by R, give you IR. Okay, you know this voltage, you know resistance, you can find IL, and you can find IZ by IR minus IL. This, if this is clear, so we can proceed further. Now you can find, you have been given the V input. V input is 10 volt, 40, 100. Okay, and Vz value is given to you 6 volt. Vz value is given to you 6 volt. Find these parameters. Find parameter means you have to find VL. Okay, you have to find VR. First find IR, VR, then find VL, find IL, and then find IZ. Right? And then last you find PZ. Calculate. So first you have to check how much is the open circuit voltage? Again, okay, what is open circuit voltage? You make it open, remove this diode, see whether enough voltage is coming or not. So V open is coming how much? This is 10 volt, total resistance 140, 140, and you want voltage across, this one means across 100. So this becomes 1000 upon 140. How much will come, tell me?
7.14.
7.14, which is greater than Vz equal to 6 volt. Okay. So obviously diode is on. Okay. So Zener is on. You can see Zener is on. Zener is on. Okay. So that means here now you can say voltage is, yes, 6 volt. Okay. So this voltage is 6 volt. So VR will be 10 minus 6, that is 4 volt. Okay. And you can find IR will be 4 volt divided by 40 ohm, that is 1 by 10. 1 by 10, that is 0.1 ampere, or in milliampere this is 100 milliampere. Okay. Now you can, so this is known, you can find VL will be equal to VZ 6 volt. Okay. IL will be equal to VZ 6 volt divided by 100 ohm, that is 0.06 ampere, that is 60 milliampere. Okay. IL is known, IZ will be 100 minus 60. IZ will be I minus IL, IR minus IL, that is 100 minus 60, that is 40 milliampere. And PZ will be your IZ is 40 milliampere, and VZ is 6 volt, that is 240 milliwatt. So is this circuit is clear to everyone? Swar Pandika, not there. Akshay, Karishma. Or should I repeat again? It is clear. Consum?
Yes, sir.
Clear?
Yes, sir.
So this is your voltage regulator. Now we'll do different cases.
सर जो जीना डायोड के क्रॉस वोल्टेज रहेगा वही लोड के क्रॉस रहेगा ना सर?
वही लोड के across रहेगा, same. We parallel, both are parallel. Okay.
Yes.
So now let us discuss some case. Case first. Case first is what? You have this V input. Okay. And here you have a resistance R. This is your Zener diode. And this is RL. Okay. RL. So first case I will take fixed VI, fixed input voltage, fixed VI, and variable RL. That is your VI is fixed, some voltage will be given. R is also fixed in the circuit. Only I can vary this RL. Okay. Now here, if this RL should have some value, minimum to maximum value. Okay. Why? If you take maximum value here, if you keep on increasing this RL, what will happen? Tell me. If you keep on increasing RL, if
Sir,
RL,
current across it will decrease.
so IL will be keep on decreasing. IL will be keep on decreasing. Okay, correct. See, assuming Zener diode is on, so this is on. This voltage is fixed. VR is fixed. This VZ is fixed. Now, if you're increasing this RL, the increasing RL will affect IL, because the if resistance voltage is fixed here, now VZ load voltage is fixed. Okay, so let me write here, if Zener is on, okay, then what will happen? Then VL will be equal to VZ, which is equal to IL into RL. Okay, now this is fixed, this is a fixed constant. Okay, fixed. Now if you increase RL, if you increase the RL, this multiplication is should fix, so IL will decrease. IL will be keep on decreasing. Now if IL is keep on decreasing, that means what will happen? IZ is IR minus IL. Okay, if IL is keep on decreasing, IZ may be keep on increasing. Okay, and if IZ is keep on increasing, there is some particular value of IL max, IL minimum or RL max. Okay, so if RL goes some value greater than RL max, then IL will become IL minimum, and when this IL become minimum, this will become IZ max. This everything is connected here. If this is fixed, this is fixed, this is on, and now what are doing? You are keep on decreasing this one resistance, and you keep on increasing resistance. The IL in this well will be keep on decreasing, and this IZ will be keep on increasing. So there is a limit. There is a higher limit on RL. You can't go beyond that one. If you go beyond that, this will burn. Okay. So if you go, so if RL is greater than RL max, okay, IZ will become greater than IZ max, and Zener will burn. Okay, so given circuit, you can't go some particular limit of RL. Similarly, what happens if you keep on decreasing RL? Okay, so keep on decreasing RL. So what will happen if you keep on decreasing RL? IL will keep on increasing. IL will keep on increasing, and if IL keep on increasing, that will affect what? IL keep on increasing, then your
Sir, IZ decrease कर दिया.
IZ keep on decreasing, and if IL become IL max, that become IZ minimum. Okay, so if RL is less than RL minimum, okay, in that case, what will happen? Your IZ will become less than IZ minimum, and the Zener diode will not conduct. It will come in the open circuit, because in that case, what will happen? The voltage here will not be equal to VZ. Okay, so in order to that voltage should come here equal to VZ, it should have some minimum value. Okay, that's why we say that RL has a two values. One should be RL minimum and RL max. In between these two regime, okay, you should choose the RL for given circuit. Okay, so let me demonstrate this with example. It is clear. This point is clear to everyone. Okay, so for given fixed VI, fixed R resistance R, this should have some minimum and maximum value. If it is not between minimum and maximum value, your diode will burn. Either it will not conduct, or either it will get damaged. Okay, so burn means it will damaged. Okay, so let us see one example. So I have a circuit, say this is 10 volt, 16 volt, 16 volt, and this is my R, this is my Zener diode. Okay, and for that PZ max is given. PZ max is given 30 milliwatt is given here, and here you have a resistance, say 1.2 kilo ohm, 1.2 kilo ohm, okay, and R value is given 1 kilo ohm, R value is 1 kilo ohm, okay. Now tell me whether this zener is on or off, okay. So find in this circuit, find VR, okay, VL, so this is VL, okay, IR, IL, okay, IZ and PZ. Find out in this circuit. First you practice on this only this circuit, okay. Then we'll change the different quantities. First you have to mastery on this aspect. This is fixed, this is variable. So tell me, first thing is what? You'll check whether the zener is on or off, okay. So tell me whether it is on or off.
So, how much is VR?
VR is 1 kilo ohm. R is 1 kilo ohm.
No, VR.
VR which what? VR you
So, what is like voltage across the that is
zener 10
uh,
volt, 10 volt. The first thing is what? You have to find the V open, okay.
Zener is off.
Zener is off, okay. So you have to find first V open. You make it open, V open. If you make V open, this one, no current will flow here. Whatever current coming directly come here. So you have to find what is the voltage here. So V open will be what actually? That will be 16 divided by this 1 kilo ohm plus 1.2 kilo ohm into 1.2 kilo ohm. Okay, this becomes 16 into 1.2 kilo ohm, and this is 2.2 kilo ohm. Okay, tell me how much is coming this one?
8.72.
8.72. Okay, 8.7 volt around 8.72 volt to 7 volt, which is less than 10 volt. So of course at 1.2 kilo ohm, this is not conducting. Now you can calculate all these parameters. Okay, of course IZ becomes 0, IZ becomes 0, PZ becomes 0, okay. And now you can find IR, this coming IR here, this will directly go here. So IR will become equal to IL, okay. And open circuit voltage is 8.72 volt, okay, across this one VL. V open is basically now VL, okay, in this case. And 1.2 divided by this one, this will give you the current value, okay. Tell me how much is coming. And VR will be your 16
7.2.
7.27.
7.27 milliampere, what?
मिली एम्पीयर आएगा सर.
This kilo ohm. And this will be VR will be difference of this one, okay. 7.28 volt. So everything you calculated, but that means now Zener diode is one thing we learned, that for R equal to 1.2 kilo ohm, Zener diode is off, okay. Now let us say I am replacing this same question, same Zener diode. I am replacing this with a 3 kilo ohm. Okay, now you find everything, calculate all the quantities again. This has become 3 kilo ohm. So now again you have to find V open. So V open gives you what? V opens gives you again 16 upon 3 and 1, 4 kilo ohm. Okay, 1 kilo ohm plus 3 kilo ohm into 3 kilo ohm. V open is give you 16 upon 4 into 10 raised to power 3 into 3 into 10 raised to power 3 cancel out. Okay, we open how much? 48 is 4. It's coming 12 volt, which is greater than Vz equals to 10 volt. Okay, so now this become 10 volt. This can be replaced by battery. This will become 10 volt on. So if this is 10 volt, automatically your VR becomes how much? VR becomes 16 V input minus Vz. 16 minus 12, that is 4 volt. करेक्ट है कि नहीं है? 16 minus 10, 16 minus 10. अब 12 वोल्ट आया, लेकिन 12 रहेगा नहीं, बनेगा यहाँ पे 10 ही. ये ऑन हो गया, 10 ही बनेगा. This becomes 6 volt. Okay, and this is 6 volt. So you can find IR. IR will be 6 volt divided by 1 kilo ohm. That is 6 milliampere. Okay, and here VL will be equals to Vz, that is 10 volt. So IL will become 10 upon 3 kilo ohm, that is 3.33 milliampere. Okay, and your IZ will be how much? IZ will be your 6 minus 3.33 milliampere, that is 2.67 milliampere. Okay, and if you find the power PZ is how much? Is IZ 2.67 milliampere into PZ 10, that is 26.7 millivolt is the power loss in the Zener diode. And the maximum Zener diode, how much I gave you? I gave you 30 millivolt. Okay, so if it is a 30 millivolt, that means still we can increase IZ. And IZ, how can you increase? By reducing IL. Okay, so now first we'll see what is RL minimum. Okay, that we'll see what is RL max. Okay, now here I have seen what? If once I have put 1.2 kilo ohm, it says it is not on. I put 3 kilo ohm, it says on. Okay, now in between those two limits, there will be some value where this Zener diode will be exactly on. Okay, when I use 1.2 kilo ohm in the beginning, in the earlier question, that time you got V open equal to 8.72 volt. And now when I use 3 kilo ohm, you got V open equal to 12 volt. So there will be some value of RL for which this will be V open will be exactly Vz. That value is called the RL minimum. Okay, so what is the definition of RL minimum? So RL minimum, okay, so RL equal to RL minimum when V open is equal to exactly Vz. Okay, and now what is V open formula? V open formula is your V input R plus RL into RL. If you keep this V open equal to Vz, then this V input RL will become RL minimum into RL minimum. Okay, using this equation, you can find the value of RL minimum. Okay, So I say now find RL minimum for this circuit. Find the RL minimum for this circuit. कितना आएगा RL minimum? So RL minimum from this formula, VZ is your 10. Okay, I'm keeping 10 here. VI is 16. R is my 1 kilo ohm, 1000 ohm plus RL minimum into RL minimum. Okay, so this will give me how much? This will give me, if I do it like this will give me 10 raised to power 4 plus 10 RL minimum equal to 16 RL minimum. Okay, and this give me 4 RL minimum equals to 1000, 10,000 or 10 kilo ohm, 10 kilo ohm. Okay, so RL minimum will be 10 upon 4 to 10 raised to power 3. That is कितना आएगा ये? 2.5, 2.5, 2.5 kilo ohm. Check it whether I'm doing mistake anything.
Yes, sir.
2.5 kilo ohm should come in minimum. No, just check it whether I done any mistake. 16, 16. This is 10 minus 10, 16. So sorry. This is how much? 16, 10, 6 will come.
सर
No?
6 आ जाएगा यहाँ पे. Yes.
6. So how much will come? Tell me.
1.6.
1.67 kilo ohm. Okay, that is the RL minimum for this given question. Okay. Can you find what is RL max now? Okay. So for RL max is what? I already given here. PZ max was given how much for this Zener diode? PZ max was given 30 milliwatt. Okay, and when IZ max is flowing, obviously this is on. Okay, so if it's now what is RL max? Okay, RL max. So RL equal to when? RL equal to RL max implies IZ equals to IZ max. Okay, so let us find now what is IZ max in this question. Okay, so IZ max you can find by PZ into PZ max is your VZ into IZ max. Okay, so you can find IZ max equal to PZ max, which is 30 milliwatt upon 10, that is 3 milliampere. 3 milliampere. Okay, now automatically when you know, so IR equals to IZ max, so automatically this become IL minimum for fixed things. Okay, so here you can find what is the value of IL minimum. So IL minimum will become, IR was how much? If this is 10, this is on, this is 10, this 16 is 6. Okay, 60 milliampere. So IR is what? IR is simply 6 volt divided 16 minus 10 upon 1 kilo ohm. That is 6 milliampere. And now 6 milliampere IR minus IZ max. That is 6 milliampere minus 3 milliampere. That is IL is 3. IL minimum is 3 milliampere. Okay, so you can find now RL max. So RL max is VL is fixed. upon IL minimum. VL is your how much? 10 volt, and this is IL minimum is how much? 3 milliampere. Okay, this will give you 3.33 kilo ohm. Okay, so 1.2 kilo ohm it was not on. Okay, 3 kilo ohm it was on. Then we found the minimum value 1.667 will also make it on. Okay, you cannot go beyond less than 1.67. 1.67 kilo ohm will make this diode on. If you keep on increasing, it will remain on. But you go above 3.3 kilo ohm, then this will burn. So this is the limit of RL minimum and RL maximum. Okay, so I hope you understood how to find the value of RL minimum and RL max. Okay, now I'm giving you a question. You tell me. I will not do anything. You tell me what is RL minimum and RL max. Is there any student who is not getting?
सर
Tell me.
सर आपने ये क्वेश्चन लिखी है आई आर इक्वल टू आई जेड मैक्स प्लस आई जेड मिन, ये कहाँ से आई सर? ये क्वेश्चन इसको कैसे समझे?
Yeah, if this IR is coming,
यस सर,
this will form equal to IZ and this one. This is equal to
आई एल,
हाँ, तो अगर ये मैक्स है तो ऑटोमेटिकली ये मिनिमम है,
यस सर,
क्योंकि ये इक्वल तो दोनों इसी के है ना. दिस IR is making IZ and IL. So
आई एल, यस
one is max, other is minimum.
ओके 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 सर, क्लियर सर, थैंक यू सर.
So let me give you a problem and you have to tell me. So ये simplest कैसे है, इसको अच्छे से समझो. ये समझ में आ गया तो बाकी भी समझ में आएगा, वरना एक वेरी सिंपल सर्किट अगर इसको समझ में नहीं आएगा तो फिर क्या किसको समझ में आएगा. So this is a 50 volt input is given, okay, and you have given R is again 1 kilo ohm, okay, and here Gina diode is your 10 volt, and this is 32 milliwatt. IZ max का वैल्यू दे दिया इस बार. IZ max पावर नहीं दिया, सीधा IZ max दे दिया. IZ max is given 32 milliampere. 32 milliampere, okay, and this IL is, this RL is varying. Okay, find RL max and RL minimum values for this given circuit. Find out.
Sir, what is IZ max? सर IZ max आपने वैल्यू कितनी लिखी है सर?
32 milliampere. 32. IZ max is 32 milliampere. Let us first find RL minimum. Okay, so RL minimum. For RL minimum, what is the condition? For RL minimum, your V open will be equal to Vz, which is given 10 volt. That will be equal to V input. Okay, Vz is what? V open is equal to Vz. That is V open is what? V input upon R plus RL. Okay, if it's equal, then it is become minimum into minimum. Or it is given 10, it is given 50, is 1 kilo ohm per 1000 ohm. Okay. RL minimum into RL minimum. This cancel out. Okay, 1000 plus RL minimum equal to 5 RL minimum. So 5 minus 5 minus 1, 4 RL minimum equal to 1000 ohm. RL minimum equals to 1000 upon 4, that is 250 ohm. Okay, or 0.25 kilo. सबका आ रहा है ये
यस सर 250 ओम आ रहा है
250
आर एल मिनिमम आर एल मैक्स आ रहा है 1.25 किलो ओम
So this at least RL minimum is very easy. Okay,
यस
now
सर
you have to find this IL max. What? RL max. So RL max is nothing VL upon IL minimum. Okay, and IL minimum you can find IL minimum. You can find IR minus IZ max. IR is given already here because here IR is what?
आयर 40 आ जाएगा
VR upon R. Okay, this 50 40. Okay, minus IZ max is given 32
32
milliampere, 32 milliampere, and this will become 40. कितना आएगा?
40 आ जाएगा सर वो तो
40 milliampere,
40 and 32 मिली एम्पियर
and 32 milliampere. That is 8 milliampere. Okay, 10 to the minus 3 ampere. So 8 milliampere. Okay, and now RL max, because it is on max. If it is max, it is a minimum. When I considering max, so you have to assume this is on. Okay, VL equal to VZ. That is 10 upon 8 milliampere. 8 milliampere. How much is coming?
1.25 1.25
Kilo ohm.
किलो ओम में आ जाएगा यस
Simple. So these calculations you should be able to do it. Okay. So shall I start one more case or it is okay today?
यस सर वी कैन स्टार्ट न्यू केस
We can start new case.
यस
So this is the first case when VI is fixed and RL is changing. Now you can make VL fixed and make it VI change.
सर आप हमें इस पर एक क्वेश्चन दे सकते हो घर से मतलब इस केस पे एक है ना
दे देंगे वरना तुम भी कर सकते हो ना इसका वैल्यू चेंज कर दो बस
हाँ यस सर यस श्योर श्योर
जो भी करके अपने आप कर सकते हो उसको और बुक है उसकी जो बुक मैंने बताई थी आपको किसकी इलेक्ट्रॉनिक्स की क्या नाम था बुक का बॉल स्टेट
वेल स्टड यस
काफी क्वेश्चन दे रखे हैं उनके पीछे आंसर्स भी दे रखे हैं ठीक है सो दैट यू कैन फाइंड नाउ द नेक्स्ट केस इज मैं भी दूंगा टेस्ट में दूंगा क्वेश्चन दूंगा अभी ठीक है so now next case is what next case is fixed RL and variable V input. Okay, that means now this is the case V input is variable R. This is Zener diode. This is your R and this is RL. Now it is fixed. RL is fixed. VL. Now I want to make this diode on. Okay, keeping this fixed and I can vary this one. So this also should have some minimum and maximum value, na? V input, V minimum, V max. Okay, because this is fixed, and if it is on, this voltage is fixed, this voltage is fixed. Okay, so if I want to make this also on, okay, so there should be certain minimum value. If this voltage is less than the minimum value, what will happen? This will not able to make this zener on. Okay, so what should be the minimum value? So for minimum V input, for minimum V input, your V open should be at least equal to Vz. Okay, and V open is what? V open is your V input. Now R plus RL is fixed, so this will become minimum. So minimum value of this one, which makes here, because this voltage only will decide what is the voltage coming here. This voltage will be distributed here and here. This will decide how much coming here. So this should have minimum voltage. Okay, so minimum voltage can be get with this formula. Okay, so you can use this formula and you can find what is the V minimum. Okay, now what about V max? And here RL also, you know what is RL value. RL value will be given the question. R will be given, so you can find. Okay, correct. Now what is for V max? For maximum V input. Okay, that is VI max. VI max. Now suppose you are keep on increasing this voltage, keep on increasing the voltage. What will happen? This current will increase, yes or no? This current IR will increase. If you are keep on increasing V input, my IR will keep on increasing. Now if IR is keep on increasing, IR is equal to IZ plus IL. Now this IL is fixed because resistance is fixed. If it is on, this is also fixed. This cannot change. So this is fixed. So automatically when you are increasing VI, IR increasing, and that is increasing IZ. Okay. So if you go above some particular limit, what will become? This IZ will become greater than IZ max. So that means for maximum V input, your IZ should be equal to IZ max. Okay, that means your so IL is known, so your IR can be calculated as for V input max. So your V input max will be now V input max will be IR max. Okay, IR max into R and plus VZ. So this V input is what here. So if IZ max is become higher, so this will become also IR max. So IR max will be IZ max. Okay, and this IL is fixed. Everything will be decided by these two currents. Okay, this is fixed. If you are increasing this voltage, this voltage is fixed. This is increasing. This voltage is fixed. So here voltage is increasing. If here voltage is increasing, here current is increasing. If here current is increasing, this current is fixed. This current is increasing. So you have to take that current. Okay. So eigenvalue should be given for calculating VI max. So using this formula, you can find the minimum and maximum limit. Okay. Tell me if it is in doubt in this thing. Sachin, Shikha, can you find out now what is
क्लियर है सर
minimum maximum?
Yes, sir.
Okay, so you can use the circuit. Okay, so let me give you one question and you have to tell me what is the value of minimum and maximum. Okay, so V minimum क्या है आपका क्वेश्चन में दे रखा है 220 ohm. This is given 220 ohm. This is given 220 ohm. RL is given 1.2 kilo. Okay, kilo. And VZ is given 20 volt. Is given 20 volt, and VZ IZ max is given 60 milliampere. IZ max because वो चाहिए हमको IZ max चाहिए 60 milliampere. This we needed. Okay. Find V input minimum and V input max. This VL. So first, let me find VI minimum. So VI minimum. Okay. So for VI minimum, V output, V open equal to VZ. That is VI minimum R plus RL. So VI minimum, put the values 20. Okay. VI minimum R is 220 ohm and this is 1.2 kilo ohm to 1.2 kilo. Okay, so ये कितना हो जाएगा? This is 1200 ohm and this 220 ohm, 1420 ohm. So 20 into 1420, okay, equals to VI minimum divided by 1.2 kilo ohm, 1200. So how much coming? Tell me VI minimum.
23.6 आ रहा है.
This is 2, this is 6, okay, and this is you got 2 times
23.6.
3.6. Check it out.
23.67 लिख सकते हैं आराम से. 23.67.
So 12, 22, so 30, 18 and 18, 4, 46, correct. Okay, 46 and 40. So this is the volt, this is the VI minimum. Okay, now find VI max. And VI max is what? VI max formula is what? IR max into R, this one. Okay. Means VI max will be that means VR will be max. Okay, you understand like VI max means this is on, this is fixed, this will be max. VR max plus VZ, and this will be IR max plus R VZ. Okay, so now find IR max. So IR max will be what? Tell me. IZ max plus IL. Okay, IZ max is given 60 milliampere, and IL will be how much? IL will be 20 volt divided by 1.2 kilo ohm. How much coming IL? 16.67 milliampere. 16.67 milliampere. Okay, so 16.67 milliampere. So this become how much? 76.67 milliampere. Okay, now put the values here. So here it will come 76.67 milliampere into 220 ohm plus BZ is 20. Tell me how much time solving this.
ये 23.88 आ रहा है,
नहीं 20 तो यही है.
तो उसकी वैल्यू काफी कम आएगी ना, जो लेफ्ट वाला पार्ट 220.
76 into 220.
-3 पावर -3 है ना. लेट मी चेक अगेन, एक सेकंड. 200.
VI max. What answer I'm writing? It should come 36.87 volt.
ये सर आ रहा है.
Other students, are you getting this one? This formula you use. VI max equal to IR max into R plus VZ. That is, I think it's visible here. 76.6 and -3 into 220 plus 20. If you solve this one, this answer will come. So I'm giving you one homework based on the same question. Okay. Let us say this is now 300 ohm. Okay. This is 30 milliampere and this is 3 kilo. Okay. So find V minimum and V max for this question. V minimum and V max. Find VI minimum and VI max. Okay, so I'll stop here. Tomorrow, one more case is there, and then we'll continue. Thank you.